Problem 4. A boat travels downstream for 65 kilometers and then upstream for 21 kilometers, taking 10 hours in the process. Its second time sailing, it travels downstream 20 kilometers and upstream 12 kilometers, taking 4 hours in the process. If the same boat sailed 64 kilometers in still water, how long will it take? Let's first write two equations to represent what we know. 65 downstream plus 21 upstream is equal to 10 hours. We also know that 20 downstream plus 12 upstream is equal to 4 kilometers. So that's our systems of equations. Why don't we multiply the bottom equation by 2.5 on both sides? So on the right side, we'll get 10. And on our left side, we will get 50d plus 30u. So if we compare this with the first equation, we'll name these equations 1, 2, and 3. Let's compare them. And we'll see that 15d is equal to 9 u's. So that is our comparison right there. So if we compare, here's a ratio now. If we compare d with u, it's really equal to 15 to 9. 15 to 9. And that also equals 5 to 3. So 65d plus 21u is equal to 10. Let's turn this u into d so everything is the same variable. So our new equation would be 65d's, and let's first see how many u's is in 21. Well, 21 divided by 3 is 7. 7 times 5 is 35. 35u is equal, 35d, sorry, we changed variables there, is equal to 10. So if we add these together, we get 100d is equal to 10. So d is equal to 1/10. Meaning that in downstream, the downstream speed is 10 kilometers per hour. So downstream is 10 km per h. And we also know that the upstream speed would be, if we divided 65 by 5, right, we get 13. 13 times 3 is 39. So 39 plus 21, that's 60. And that would travel 6 kilometers per hour. So remember, in water sailing problems, downstream is equal to the ship speed plus the water speed, and upstream is equal to the ship speed minus the water speed. So what is the middle number in between 6 and 10? That would be 8. So we know that the boat speed is 8 kilometers per hour. And the question is, if the boat sails 64 kilometers in still water. So we just divide 64 by 8, and that equals 8. So it would take 8 hours. So even though this was a ship on water problem, it's also a type of itinerary problem. And we also used ratios along with our systems of equations. So thank you for watching with your Inquisitive Kids, and see you next time.